Hello, and welcome to this video about revenue management and price optimization. We hope you enjoy it and that you learn something new. So, what are the initial problems and aims of this video? Firstly, we would like to look at how we can exploit revenue. Industries that are subject to revenue management deal with the fact that if a service or product is not sold on that exact day, the revenue is lost forever, and this should of course be avoided. Secondly, we want to optimize revenue, which aims to outline how the airline industry can effectively maximize their revenue through intelligent segmentation. Lastly, we want to answer the question of how we can more realistically depict demand in the airline market. This video aims to show you a realistic inverse demand curve and show you how you can derive and set up an exponential demand curve. In order to be able to use the methods and techniques of revenue management, the following prerequisites must be met. There should be no stocks for future sales, fixed short-term capacity, low marginal cost, demand must be able to be segmented, and it should be fluctuating, and there should be a pre-sales of services. Considering these prerequisites, and given that the roots of revenue management lie within the airline industry, we will be using the case of Swiss Airlines. Firstly, let's find a realistic inverse demand curve. To do this, we used actual data from Swiss Airlines. Namely, we chose a regular flight flying from Zurich to New York occurring every day 4 times a day, which has constant prices for each flight, giving us 3 different willingnesses to pay of Swiss's customers. We use these prices and enter them into our Excel sheet. To derive the inverse demand curve, we further require the amount of customers willing to pay said prices. To do this, we analyze the seat allocation of the flight LX60. The Airbus A330-300 has 183 economy seats, 45 business seats, and 8 first-class seats. These values again are put into the Excel file. From this data, we derive our inverse demand curve, while the area of seats serve as our capacity constraint. For this constraint, we assume that 1 first-class seat is the equivalent of 3 economy class seats, and 1 business class seat the equivalent of 2 economy seats. Using this ratio, we determine the area of the plane by multiplying the amount of space a seat takes up by the number of seats available. This can be summed up to find the total area in the plane. Now that we know the total area in the plane, we know the capacity constraint of the plane. Important is to note the fact that the assumption made here is that prices indicate the willingness to pay of 3 different customers. As such, for first class, 8 people are willing to pay the price of a ticket worth of 8,324 francs. For the next segment, 53 people, which is the sum of 8 and 45, are willing to pay this price for a ticket. Finally, for the last segment, all customers within the capacity constraint are willing to pay the price of an economy seat. Revenue can be easily determined by multiplying the number of seats by the ticket for each seat. Again, this can be summed up to find current total revenue. The higher willingness to pay, together with the price, allows us to derive an exponential inverse demand curve. Highlight the corresponding values and insert a scatter graph. This will plot the points from which we can derive the inverse exponential demand curve. The curve shows the demand curve derived from Swiss's 3 different customer segments. Subsequently, we will utilize this inverse demand curve to optimize the customer segments and optimize revenue. First, however, we need to add a trend line. Select an exponential curve, not a linear line, because this allows for a more accurate and realistic demand depiction. Ensure that the equation is displayed on the chart and enter these values into the Excel file to allow you to determine the price for each segment. Enter the formula of the exponential inverse demand curve, which is dependent on the number of seats. Multiply the constant a by the Excel formula for an exponential function, exp. Inside this function, multiply constant b by the amount of customers. Remember to set $signs on constant a and constant b to allow you to drag the formula down for all segments. Next, arbitrary values for the amount of customers per segment are set. Important is to keep in mind that we need to use the aggregated number of customers, not the seats per segment. Multiply the amount of customers by the price to get the revenue. For business and economy segment, however, the amount of customers in higher segments need to be subtracted. Sum these values to get the total revenue. To ensure that our segmentation stays within the limits of available area on the plane, we need to calculate the seats per class to determine the overall area of seats. Multiply the above ratio determined for the seats in the plane by the number of seats, and take the sum of these values to determine the total area of the seats. This will serve as our capacity constraint. Now it's time for some Excel magic. We will use the solver to maximize our revenue by creating segments with optimal prices and seats per segment under the set constraint. We set our total revenue as our objective, since this is the value we are trying to maximize. The amount of customers is set as our variable cells because we can only set an integer constraint on our variable cells. Accordingly, we set our first constraint that our variable cells must be integers, which is a number that can be written out without a fractional component, as you cannot have half seats in a plane. Secondly, we add the area constraint. Then we can let the solver do its magic, and ultimately we end up with the optimal number of seats for each segment, along with the corresponding prices, which result in the maximized revenue. As you can see, there is a very high gain in revenue of 84,230 Swiss francs compared to the current segmentation used by Swiss. As such, we could increase the revenue to 125% of its original value. Therefore, we have managed to optimize revenues for Swiss and reap the benefits of segmentation and its according pricing strategy. Thank you for listening, and we hope you enjoyed this video.